All right, so yes, last time we started off trying to give you all the definitions. So having all those formulas handy. We're going to start some examples. This is, I think we did one example, right? So we did example 2. So we're going to do the one solution case. So on the exam, I'm not going to tell you if there's 1, 2, or no triangles. You need to find out yourself. So so here I'm telling the example that it is only 1 triangle. Okay. But I'm going to show you how you check, because you need to check yourself. So this example only gives us A equal to 45 degrees. It does not give me angles B or C. It gives me little a, 7 square root 2, little b equal to 7. Little c is no, not good. So we only have these 3. Okay. Now, you need to start getting used to these problems. So which piece would you want to solve for first? What makes most sense? Can you see? Yeah, and we choose B because we have an opposite side. The C's are both unknown, so I can't really mess with that. So this will be later. The best thing to start with is B. It's actually your only choice. Okay, so step 1 here. Solve for B using law of science. So I'm going to isolate sine B and then plug stuff in. So sine B over little b is equal to, and I try to use what we were given because this is exact. And I know that I didn't find those, so that means they have to be right. I haven't messed it up, right? So cool. So isolate sine B by multiplying both sides by little b. I'm going to skip a little bit of algebra. Let me know if you missed it. All right, multiply both sides by b gets me here. Sine b is now isolated, so cancel sine with your inverse trig. Okay, and now we're ready to plug in some numbers. B is equal to sine inverse of b sine A over little a. Little b is 7. Let me write that. 7 sine 45 over 7 root 2. So at that point, it's calculator time. And we have angle B. Cool. 30 degrees. So we have B. So once you find B, you need to check. Remember we said whenever you're using inverse sine, there's technically two solutions, right? So check both. So right now I'm gonna assume maybe there's two, I don't know. We'll call it B1 and B2. B1 is 30 degrees. B2 is equal to 180 minus 30. Okay, so part two. Check if both B1 and B2 are solutions. If they are, then you have two triangles. If only one of them works, then you have one triangle. Okay. That's how you check. All you got to do is add to the original and check if it's less than 180. So since A plus B1 is equal to 45 plus 30, which is 75 degrees, is less than 180, then it's a solution. Okay. Since A plus B2 is equal to 45 plus 150, which is equal to 195, right? Since it's not less than 180, then it's not a solution. So that this is what tells you that there's only one triangle. Okay. So always trying to find both and then check. Once you see that one of them violates it, right? Because you can't have a triangle that adds up to 195. We still haven't even found angle C, right? So how would you get a third angle if it's already above 180? See what I'm saying? Over here, angle A and angle B is 75, so we still have room for angle C. So this tells us we only have one triangle. Is there any questions about this? You're gonna need to check yourself.
Could you do one with two correct solutions? And then,
Yeah, that'll be the next example.
Yeah.
Those will be long and difficult. So you're hoping there's only one. Those are doable. Even better, you're hoping there's no triangle, because then you don't have to do anything. But when you get two, that's when life sucks. Okay, so we'll do that one next. That's cool in this pace, though. All right. We got B. So what's C gonna be? I'm gonna box the ones we find so I know what was unknown. What'd you get? Oh, that's not right. So we got another answer. Cool. Now that I have an angle, I should be able to find little c, right? Using the law of sine, just like we did here, kind of. We'll do that on the next page. 105. Do step 3 right here. Angle C is equal to 180 minus 45 minus 30, which is 105. So as soon as you get two angles, just go ahead and find that third right away. Okay. Any questions on this problem so far?
Why is there B1 and B2?
So there's always two solutions. If you look at, do you have a unit circle on you? No, maybe.
Yeah.
If you notice, there's just more than one location that satisfies sine. For example, if we had a sine value of 1/2, 30 degrees, right? Another sine value that has 1/2 is 150. See how both of these answers would satisfy an equation? So I have to always use, so I'm always going to have two b's, but only one, or, well, I guess let me rephrase that. You just got to check if both of them work, or one or neither. Okay. So you find the b like using log signs, then you find its pair b2, and then check. Okay. It's only, well, once you find if both work, then you'll have two different c's. You'll find it just like we did the 105. The a will not change because that one's fixed, which we'll talk about in the next example. Okay. So we had two. The only this one was the good one. Okay. Any other questions on this page? All right, so let's find a little secret. Solve for C. So start with sine C over sine C, capital C. Set it equal to any of the stuff you have. I'm going to choose the one they gave us to begin with just because it makes me feel better. Multiply both sides by sine C to isolate little c. Little c will be equal to a sine C over sine A. Plug in all your numbers. 7√2 times sine C with 105 over sine A, which is 45. Oops. Let's say 13 point. Let's round a one in this one place. Little c is 13.5. Sure you got everything correct. Let's go back there and plug it in. 13.5. So yours simplified it. What kind of calculator you got?
Yeah, it's exactly.
Let me pull that guy out. Hold on. It is in degrees, right?
Yeah.
You see this button down here above the enter, second, and then press that enter. It should change it to decimal form.
Okay.
Got it? Was it the same?
Yeah.
Okay, cool. One's exact and one's approximated. A lot of these will be in decimal. There's not very many. Only the really pretty questions will be exact. This is more of an applied section. And real life is ugly. Okay, any other questions on example 2? Let's do one with 2 triangles. This one. Okay, probably only like a couple pages for this. I'll turn the page. So this is a 2-solution case that the book calls it. Okay, so I'm gonna go ahead and write down what they gave us first. I'm gonna call it A1 and B1 because I know there's gonna be 2 sets just to keep our stuff together. A1, 43.1 degrees, 186.2. Capital B1 is not given to us. Little b1 is.
136.2.
Yeah. B1 is 248.6. C1 is not given to us. Little c1 is 257.2. Okay. I'm gonna go ahead and write
252, 257.
257.2. Now, only certain one of them, certain one of these parts here will be different from triangle 1. So let me try to give you the visual so you can understand which ones. Now, the A and the side A are fixed. So this is going to be the same. That's what they gave us. These don't change. Okay. Now, let me draw you a picture. So here's A. So that one just opening that way. Hold on. Let's try to stay on that line there. So there's going to be more than one B and more than one C angles. So that A, or sorry, that side A opposite to angle A is going to either open inward or outward. Does that make sense? So it's like it's flapping in or out. So that's why you have 2 solutions. So either A, it's coming down here somewhere. Right, we'll call that B1. Or it's coming down here. So do you see why there's two different B's? It's just this length that's coming in and out, that's the same. So either it flops out or in. So that's why it didn't change. Side A, or this could be side A. The A's are the same.
A is the only, like, A is the only one that always stays fixed.
That one, but also little b is not being messed with at all, right? That one's just there. This is also fixed. So you need to be able to determine, well, it would be nice if you could see which ones are fixed and which ones are not. If you don't see, then when you're trying to solve, you end up having to solve for extra stuff, and you end up getting the same thing. So you would waste time. Anyway. And of course, this is like side C, but it could be here or it could be there. So C1, C2. This visual makes sense to you. You see why we have two triangles. It's in these types of scenarios. Okay. So when we start solving, yes.
So that means small c is same to
Small c, no, because if it closes over here, then it's smaller. If it closes over there, then it's a bigger triangle. The small c will shift depending where side A lands based on these angles. Okay. So we should try to find angle B. That's where we should start. But drawing this out kind of helps us visualize what's fixed and what isn't. Okay. So let's start here. So step one. I guess step one is draw a triangle. Step two. Solve for angle B. And once we find B, we'll find B2. So sine B over little b is equal to, I'm going to use the one they gave us. So it looks like A is also is good again. You can choose whatever you want. Just make sure you have only one unknown when you start solving. If you have two unknowns, then you pick the wrong thing, right? Solve for B. Multiply both sides by little b. That gets me to here. Do sine inverse of both sides. That gets me to here. Okay, so that means that capital B is equal to sine inverse of all this garbage. B sine A over little a. So sine inverse of 248.6 sine of 43.1 over A, which is 186.2. So I highly doubt this will be a pretty number. It's going to be a decimal. What is that?
Uh, 65.81.
Nice. That makes me feel better about what I got. Same thing. Thank you. We got angle B. That's going to be B1 though. So if this is B1, how do you find B2?
I think we do the same since we have. You're gonna calculate, we're gonna say like sine A again, capital A over A equals sine B, if you side, over B, which are really same like sides and same angles.
No, sine B would be different because it's going to be over here. See what I mean? One, it's going to be. I think it might be oblique. So if we find the other one, 180 minus 65.8, what is it? 1. $14?
114.2.
Okay, so the bees will be different. Now, you need a test, even though we know that I already told you that there's two triangles, you need a test, right? That's what you're supposed to do. We'll do that on the next page. But I'm going to go ahead and write it down up here. 65.8 degrees. B2 is 114.2 degrees. Which means we can find the C is no problem, right? If you have two angles, you should be able to find the third one.
180 minus 43.1 minus 65.8.
Yeah, we'll do it right here, I guess, it's amount of space. 180 minus 43.1 minus 65.8. What do you get? Excuse me. $65. It's 71.1. Right?
No, 71.1.
Yeah, 71.1. I'll do the same thing for C2. So I got another answer. Cool. So 180 minus 43 minus 114.2. I'm just subtracting the ones we have, right? That's all we're doing. I'm trying to save space because much to find. Yeah. Okay. Let's go on this page so we can do the testing part because you need to do it. On the exam, I'm not going to tell you how many triangles there are. You figure it out yourself. That's cool on this page. All right, so step 3, I guess. I'm going to go ahead and write it over here. Step 3, find angles C1 and C2 by subtracting A and B from 180. So that's what we already did. Step 4. We should technically do the testing first, but it's okay. Since A plus B1 is equal to, what is A? 43 plus 65 . that would be 152.3. Since that is less than 180, then B1 is a solution. Since A plus B2 is equal to 43.1 plus the other angle was 114, right?
The 43 plus the 65, 152.
Yeah, is that wrong?
Yeah, that's like 108.
114.
Unless there's some out.
No, no, you're right. I think I got it backwards. So this was what, said again? 108?
Yeah, it's 108.9.
Thank you. This one I think is the one. Yeah. So the 43.1 plus 114. Since they're both less than 180, we have two triangles. Does that make sense? So since B1 and B2 are both solutions, then we have two triangles. That's when you go back and find C1 and C2. Technically, you do this first. Okay. But since we already knew it was okay, wasn't a big deal. Okay. So final step is find C2, lowercase c2, and C1. We have no choice. Step 5 here. Find C1. So C1 over sine C1 equal to A1 over sine A. Solve for C1, that'll give us A1 sine C1 over sine A.
See one was given to us.
Was it?
Yeah, we need to
Oh, I'm sorry. We need the
see two. Oh,
what? Yeah, it was. So I'll be need C2. Oh, actually, I screwed up. I gave you the answer back. So it's not supposed to be given,
okay.
but that is the answer. I did this earlier, like about an hour ago. So I just wrote my note down back then. So let's go ahead and solve it. So it was not given, C1. But this is how you would find it. So plug in everything we know. A1 is 186.2. Sine of C1 angle is 71.1, right?
Yeah.
over sine A, which is 43 point. So that gives us the answer that we had earlier. 257.2. That's where it came from. It was not given. C2, it's almost the exact same thing. Technically, A1 and A2 are all the same. I'm just making this, labeling it as 2, so you know that you're supposed to use stuff from triangle 2 to solve things for triangle 2. Don't use things from triangle 1. Multiply both sides by sine C2 to get this guy. So that will be 8 to 186.2 times sine 71.1. That doesn't change. Or does it? T2 is 22. My bad. It is. Sine was the same. Okay.
Then don't forget sign inverse, right?
Oh, we were just finding a side. So we're
Oh,
inverse only for angles. 186. 186.2 sine. Yeah, 105.2. Any questions on this example? Got all the sides and all the angles for both triangles.
So this is only on sine, it's not cosine.
Say that one more time.
Cosine would be.
Like the log cosine, is that what you're asking if we can? Well, only if it fits cases 3 and 4. We haven't done log cosine yet, so that's going to be soon, but technically when you find certain things, okay, let's say I find like B or side C or something, I will then might be allowed to find or use log cosine. So technically you could, because right when you first start, was the NC2 was 105, right? Boxes for later. When we first started, we had everything that was not boxed. And for triangle 1. So here I had to do log sine because I didn't have all the sides. Most of the log cosines require all the sides. So again, that's 6.6. So we'll wait. Any other questions on 3? Let's do one where there's no triangle. That's the best one. This is the worst one. So if this happens when you're working on a problem, just stop and say no triangle. No solution. No solution case. Make sure I write down the right stuff here. They gave us angle A. Gave it a side A. Capital B was not given. Little b was given. None of the C's were given. So we should start by looking at B, right?
What's the B, 122?
122. So when you're solving for this, you're going to get an error. And then when you see that error on the calculator, that's telling you there's no solution. And I'll explain why in just a second. So we want to find B. So start with sine capital B over B. Set it equal to the stuff that you have. So sine B is equal to B sine A over A. Sine inverse of both sides. I need that capital B free. So B is sine inverse of B sine A over little a, which would be sine inverse of 122 sine 42 over 70. So this should tell you that, well, this number inside is bigger than 1. If you can't see that, or if you don't see it, that's okay. You're going to see it on the arrow. But this should be a red flag telling you there's no solution for this, for capital B.
Wait, how do we know that? How do we say here?
But you're going to get an error because the input is larger than 1. It cannot be larger than 1 because the domain for sine inverse is between 1 and -1. So this right here is,
When you're looking at the one, you need the 122 and 70. Oh, okay.
yeah, all this right here is bigger than 1. It's like 1. Yeah, it's too big. But let's see it. Let's see what happens, right? Let's pretend that we couldn't tell that was bigger than 1. We should get domain error, yeah. That is correct. So we got an error. No solution. So just stop. There is no triangle. Visually, do you know what that means? It sounds weird, right? There's no triangle. What does that mean for all those sides that they gave us?
Shape.
Yeah, like the shape basically, it doesn't close off. Like you could have something like
It's like organic. It's not.
it just kind of stops. It's not large enough. There's no combination that'll make it connect into 3 sides. So it just doesn't make any sense. So we have an A and a side A, but it never closes.
Is there a type of map that describes those kind of shapes?
Geometry. Geometry gets very in depth. Like there's a whole field of it. It gets weird too. But I would just say it's just a bunch of line segments. It doesn't become any shape really. Okay.
So do we put no solution as a whole, or do we go to that solution right now?
Just if there's no triangle or no solution, either way, it's fine. On an exam, say no triangle. Right, you should see it as soon as you set this up. That is enough for me to know there's no triangle. Okay, and you should know it once you see the error. Any questions on 4? Right, so there's a bunch of triangle problems, solving for different sides, different angles. Some will have 2 triangles, some will have none. Okay. By the time you finish it, you should be a pro at law of sines. I've extended all the homework since we're off Friday. I don't know if you got my message. I forgot that we were off for oyster bait. So that means that's pushed the exam back. So it's probably going to be next Friday. Okay. I don't think we can do Wednesday. Would be way too early if we're skipping Friday. Okay, so we're going to start 6-6. I'm going to introduce all the formulas, and then on Monday we'll hit 6-6 hard and start our viewing until Friday. Okay. That's cool on that page. I already posted all the homeworks with the numbers and the due dates. These are all the formulas you're going to need for 6-6. It's not there? Oh, okay. I'll double check. Right? I'll fix it. 6-6 there, either?
Yeah.
Yes. Okay. 6-6, the law of cosines. Oh, quick. I guess tip. Forgot to tell you. When you're doing these problems, finding sines and angles and whatnot, if you're given 2 angles, then you're guaranteed 1 triangle. You don't have to worry about it because you already have 2. So there's no way that since those are fixed, there's no way you can like shift in or out, right? Does that make sense? So if you're given 2 angles in any problem, it's safe to assume you have a 1 triangle. That's my tip for you. Okay.
Or no triangle.
Yeah, that could happen. Well, you're given 2.
I guess it'd be obvious, like,
I want to say that's probably going to exist. It's probably going to exist. Although I don't have a theorem in my head that says yes. I'm going to say it 90% of the time. There's 2 angles. There will be a solution. I need to look that up though. I don't remember. Remember that detail. But it's my own tip that I've made up. So there you go. Cosines, plural, yeah. Law of cosines. I like cosines a little better because if you're dealing with case 3 and case 4, which is when you use law of cosines, you don't have to worry about multiple triangles. You just do the work, find the PDs, that's it. Okay. So case 3 and 4 is kind of nice. So you use this when you have nothing but sides and no angles. So when that happens, obviously you have 1 triangle, right? If you're given 3 sides in a question, there is no way a second triangle will appear. Does that make sense? I guess it's just how it is. And they're also technically telling you that 1 triangle exists. Okay. All right. So here is the first formula. A squared is equal to b squared plus c squared minus 2bc cosine A. B squared is equal to A squared plus C squared minus 2AC cosine B. C squared is equal to A squared plus B squared minus 2AB cosine C. So if you need to find one of the sides, so let's say I want to find angle A or side A, sorry. I need to have all the other sides and angle A. Otherwise, I can't use this. See what I mean? So if you're looking for sides using law of cosine, you better have at least two sides and an angle. Okay. Cosine A is equal to B squared plus C squared minus A squared over 2BC. Now, I solved this earlier for you. So let's say, you know what, I don't want to think too hard. I just want to get A. Yeah, A is equal to the inverse of both sides, so you can use this guy. This one is not in the book, so feel free to use this. Right, it's just an, what's the word? Consequence of this one. Cosine B is equal to A squared plus C squared minus B squared over 2AB. Solving for capital B would give us this. B is equal to cosine inverse of A squared plus C squared minus B squared over 2AC.
AC or
Maybe, right?
Yeah, should we see that?
The first part you put 2AB as the denominator, one should be 2AC.
Yeah, that's right. If I solve for it here, I should have a C at the bottom. Yeah. If I were to subtract this over, hold on. Yeah, that's right. Sorry about that. Thank you. I'm glad you caught it. I would hate to give you fake formulas. That would be horrible. The April Fool's, guys, it's all fake. The worst thing to do. 2AB. That reminds me of my dad texted me the other day saying he needs a stove. He's super broke, like hardcore broke. So I bought him a stove. It's being delivered on April 1st. He's like, he texted me the other day, hey, you really want me a stove or you messing with me? I'm like, we'll see what happens on the 1st. Nah, I got this. That would be so funny, it would almost be worth it. 2AB. So capital C would be A squared plus B squared minus C squared. Okay. Last formula, and then we'll call it a day. Area of the ABC triangle. So remember, don't use Pythagorean theorem for any of these problems, right? We've been doing all these fancy, complicated formulas because we can't use Pythagorean, right? So don't use that by accident. Like we have an area formula because it's not a right triangle, right? We can't just do 1/2 base times height. When it comes to the exam, please don't do that. This is called Hero's formula. It's spelled Heron. Yeah, it's spelled Heron, but it's pronounced Hero, I believe. It's some Greek name, Greek last name. They did most of the pre-calc came during that era. Ancient Greeks.
That's an S or a 5.
S.
S.
There are no 5s anywhere on this page. Promise. So S is defined, I forgot to tell you, is 1/2 times A plus B plus C. So you add up all the sides, divided by 2, that goes in here. S minus A times S minus B, etc. Okay, so this will give you the area of a triangle, of any triangle.
Is S minus A?
So there will be a question on your exam where I'm going to tell you find all the angles, find all the sides, and then right after I'm going to tell you, okay, what's the area of that triangle? So make sure you have those sides, because you're going to need them to do this. Okay. All right. If you have any questions, homework problems? How much time we got? Some time. Anything you're guys struggling with? Any concerns? So if you want to stick around for a bit, feel free. Now I'll see you Monday. We're going to continue 6-6 Monday. What's your question? Thinking about it. I don't know. Depends. I feel like blowing money or not. Yeah. Let's see. First page. There. Stop it. Oh, still recording. No. But, I'm gonna put it up today, right? Yeah. Wait.
Well, I guess whenever I got in, it was already pretty much at the bottom of the page, so I didn't find anything. I missed it all. So, okay, now I do have a problem. When I was doing the homework 6.2, I didn't turn it in because I got so confused. I didn't even finish it like I said I did because I got that confused. So I was like, I wouldn't even work and said,
Yeah, I saw your message. I was like, shoot, I need to think about it. But I think you're right.
It was a lot of stuff that we didn't even do. It
Really?
was on here, and I was like, wait, what is this? Why is this? What is this?
Yeah, show me. Maybe there's a few questions that shouldn't be on there, or maybe they're just a little different.
It was different. I want to say it's different. I remember seeing some of these questions, or maybe I've seen it wrong,
All right.
and I thought I was finding a way to get them right, but at some point, I found it. Popped up that I didn't see. You just try to solve here. Hey, it's square. Number 9, I didn't figure out.
Number 9 on 6-2, right? Scan this last one. Then if I don't scan it now, I'll never will.
I'm gonna waste it.
All right.
That's why I was trying to write it down, so if I don't write it down right now, I'm like.
Gotcha. Okay, so
Number 9.
Yeah. Was that important? Huh? Was that?
Someone asked a question, 6 to number 30 something.
Was that? Okay.
It was number 36 on 6.
There's a thing.
So I had an issue with the these types of problems. Number 9. Are you using your calculator? What are you doing? Oh, that's wrong. Yeah, it's basically, it's just putting the angles in their places, so it makes you think about it a little more. So I'm just doing number 9. Yeah, I had some people ask about that. And they had a similar question, like,
What the heck is it?
I was like, well, why aren't my notes working where the notes wrong with what one person asked? Like, no, it's just, you need to remember why you have to mention their face on the location of the data. So those betas are different places now. Right? So same thing, that's different places. So number 9. Right angle. You got an alpha over here. And a beta over there. And then we have 3 and 5. Right. Find the hypotenuse, that would be 25 plus 9.
Wait, so I. Oh, so you times them by each other and you add them together.
Yeah. Right.
Oh, okay.
So you get 3 squared plus 5 squared. That's 9 plus 25. 5, right? Alright.
25.
But I mean, that's C squared. So you square root this guy. So C is equal to square root of 34.
tap 3417. Doesn't,
And this is where,
yeah, okay, so that's gonna be on your side.
when-
So the question says,
yeah.
find part A to sign up. Okay. Sign out. Right there.
Yeah.
So here's the outline question, the angle question. Opposite is now 3 over hypotenuse. See what I mean?
Okay, so it's the same as that zero with that little two thing, it's just a different sign.
Yeah, then they tell you to find cosine theta. Part A. Cosine theta is at the top. So now the adjacent side, cosine theta is right there.
Okay, so this cosine alpha,
Cosine alpha we have, this is adjacent. Over hypotenuse. See what I mean? Here, let's do both. Let's forget a question and let's do all of them. Cosine alpha is 5 over root 34. Right now, sine theta, root sine theta. Right? Opposite is to the angle theta.
five,
It's 5.
35 over.
Hypotenuse.
So the hypotenuse is the same,
Yeah,
everything else shifts.
everything else should.
And then the cosine to theta would be, over 34.
Yes. So it's the same stuff, it's just you need to remember, when they give you the definition, that was the specific location of theta, and theta was there. But it doesn't have to be. It can be on top. It's always opposite to the angle that we're talking about. That would be sine. Adjacent would be adjacent to whatever angle we're talking. It's not always the same spot.
Okay, but hypotenuse stays the same.
Yes. There's only one hypotenuse.
But this one, that's,
Probably, maybe.
I don't know.
It's the same stuff, right? Just in a different spot.
So, number 25. Yeah. I'm talking about, yeah, same one, 20.
It's two, right?
Let me change the words to multiple answers other than the answer.
This one has a key, I think, combine.
Because some of these questions, whenever you move, you shift it over, you plus the shift over. To like on number 23, I know I'm having that. On number 23, when I did the math, I wanted to subtract 25 from over where it is, over to 36, which would have been a different answer. Yeah, question. It would have been a different answer. But when I looked at the answer, the only way I could get 61 would be to add 25 over to 30.
Well, yeah, because you gotta do the entire curve.
Okay, so,
You gotta build a triangle and find that hypotenuse like it did.
okay, but in another question, I had to subtract from it. So over here on number 7, I subtract 4 from 9 to get 5. So why is that different? Number 7 and number 23.
It all depends on what you're solving. Are you
Um,
solving for a sine or are you solving for a hypotenuse? That's kind of formula. To move things around differently. Right, if I need A, well, unless we can add sine. If I need C, then I just need to add these and square root.
okay, so did I do my math wrong?
Maybe.
Because what I got was
So you're doing
I'm like, I thought it was. Number three, I thought number three was the adjacent. Number two was the opposite. And then was, I thought it was. Am I wrong?
I believe you're right. That looks like a comment to me.
Okay, so whenever I did my question, I did two, for A, and I did three for C, and B, I left.
Well, A and B are open the sides.
Right.
So you come in from the side, or you come in the columns.
for my plan. Ah, so I'm looking for C,
C is always good.
and that's why. in the-
A and B are the latest. C is the longer term.
But it still won't make sense because if I did it that way, then it would be a bigger number.
That's why that should be fixed.
It would be a bigger number. That'd be 13. And that was the answer, 13.
Yeah, it's not right. Square root of 5 is too small.